Hi, my name's Frank Foti, and I'm the, I guess in Italian you could say Il Padrino of the Telus Alliance and the founder of Omnia Audio. I'm here today to talk about a new technology for FM transmission, which is called Omnia Direct. The simple explanation of Omnia Direct is we're now able to do couple an FM audio processor to a transmitter utilizing the multiplex signal over AES, and this is why we call it Omnia Direct. As of now, it is available in Omnia 11, and it works with the Nautel NV series transmitters. And obviously I could play processing all day, but I think what would be best for the viewers of this video would be to give an overview of the different ways we can couple an audio processor to the transmitter and where the benefits, strengths, and weaknesses are. Believe it or not, there is technology behind what Omnia Direct is all about. In this diagram here, we can talk about the various ways that a composite signal makes it on the air into an exciter or a transmitter. Up until now, an audio processor that contains a stereo generator or the output of any stereo generator that is connected to an exciter, it's all done in analog, where there's the composite signal that passes usually through a BNC connector and a RG58 cable right into the exciter. In the case of an analog exciter, it goes to the modulator. In the case of a digital exciter, it has to be resampled and then sent to the modulator. In the all-digital path, which is the desire of all broadcasters today, the use of a digital signal processor to connect to an exciter would require the use of the AES-CBU stereo left-right signal connected to the exciter. In that case, what we have is left-right audio operating at 32 kilohertz sampling or higher, and then it's connected into the exciter, to which the exciter will then provide the stereo generator and then couple that into the modulation section. When doing that, there can be some annoyances or anomalies that can occur to undo some of the precise peak control as provided by the audio processor. By example, most digital exciters will employ a form of sample rate conversion because the exciter will have a set targeted sampling rate, and it will not know what the output sampling rate is of the audio processor. When the sample rate conversion is done, even though it is a linear process, and we have a very simplistic block diagram here of how a sample rate converter operates, there's some upsampling done in the SRC, then a low pass filter to make sure that there's no aliasing products that are generated, and then a downsampling function that goes to the new targeted sampling rate. While even though that's a linear process, this little low pass filter here, which is set or targeted at the Nyquist frequency of the new sampling rate, can introduce some overshoot, which is undone modulation. Our goal in Omnia Direct is to basically recreate this example, but enable this connection to be the composite signal in the digital domain. Down below here, this is the now block diagram of what Omnia Direct is all about. Again, it's MPX over AES. What we're doing here is we have the MPX signal coming right out of the stereo generator with precision peak control in the audio processor, and the transport is the AES path, except our sampling rate is at 192 kilohertz. The beauty of this connection is we're using a standardized known method of connecting from the audio processor into the exciter. This is nothing ad hoc, nothing proprietary, nothing that's going to need some special standards or government regulation approval. So now what we have is we're able to create an electrical linear connection from the output of the stereo generator right into the digital modulator of the FM exciter. Now somebody might think, well, is there a benefit to this? Well, one, we've eliminated sample rate converters. Two, we've eliminated a D to A and an A to D function that would be in the existing method of being able to send composite to the exciter. But there's a sonic benefit here. The fact that we have this firm, direct, linear electrical connection to the modulator means that whatever peak control is done here, the transmitter is going to faithfully reproduce it and put it on the air. Sonically, that comes back in improved high frequency sound to the texture of your processed audio, a firmer, tighter, solid, low frequency response, because we're not having to worry about low frequency tilt or any of the anomalies that we've had in the past. And we have basically we've created the optimal direct connection from the modulator, from the audio processor to the modulator. There's an additional benefit that does need to be shared. I know that in numerous international broadcast applications, there is a desire to route point to multi-point the broadcast signal with precise peak control. Having this capability now in a country where they have high-speed AES capabilities to handle 192 kilohertz sampling, the signal processor could be set at a network location, and the output of the stereo generator can be sent to many different points and connected directly into the transmitter. This function is available, known as Omnia Direct, in the Omnia 11, and it's also part of the NV series of transmitters as developed by Nautel. I do know that the Nautel version 4 software package for their series of transmitters does support Omnia Direct, as well as the Omnia Direct functionality is available beginning later this summer, 2013, from Omnia Audio. If you have any additional questions, you can check our website, which is www.telosalliance.com, or contact your representative at Nautel for further information. Thank you.